Section 2.5 continues with writing the function in linear factorization, or as a set of linear factors. For f of x, the first thing I'm going to do is maybe consider what are some possible rational zeros. Using the rational zeros theorem, I know that my rational zeros might be 1, 2, 4, or 8 divided by any positive or negative version of the factors of the leading coefficient, which would just be 1. So I'm going to dive in. I'm going to try 1. Hopefully this will result in a 0 remainder. And then I know I will have found one of the factors. So drop and multiply. And this gives me -7, and -7 and 5 gives me -2, and that's -2, and that's -8, and that's -8, and I end up with a 0. Yes. Awesome. So x equals 1 is one of my zeros. It's one of my x-intercepts. I can even take this one step further and write it as a factor. X minus 1 is one of the factors of f of x. Try something else. Now I'm going to try -2, and I'm going to do that on the depressed polynomial. So notice how I'm transferring down, all of this. In fact, I could have just written it. I could have done the synthetic division right off of that. So here I am again doing some, what is this, synthetic division. This is going to give me -4, and then that gives me +8, which gives me 0 when I add. Woohoo, I found another 0. All right, and actually I found another factor as well, x plus 2. So now I'm down to, I see a pattern. 1 and a -4 and a 1 and a -4. That seems like a pattern to me. I'm going to think about this as a depressed polynomial. Remember that this was x to the 5th, and then this was x to the 4th. Now this will be x to the 3rd. What could I do with all of this? Let's see, this pattern strikes me as something that could be factored some other way. Well, I have an even number of terms, 4 terms. Maybe I can factor by grouping. Out of the first group, I could factor out x squared. I'd be left with x minus 4. Out of the second group, I can factor out a 1, and I'm left with x minus 4. Both groups have that common factor of x minus 4, and I'm left with x squared plus 1. All right, let's see where we're at. We have f of x is equal to x minus 1, x plus 2, x minus 4, and x squared plus 1. Now, this is really good, but x squared minus 1, this is a quadratic factor. That is quadratic. So what I need to do now is factor that into something that is linear. So if I set it equal to 1, I can't factor it, using the difference of 2 squares because this isn't the difference of 2 squares. All I really know to do is maybe set it x by itself. And then the square root of -1 is going to be plus or minus I. Okay, so what I'll do then is replace x squared minus 1 with x minus I and x plus I. Now that's a linear factor because the x is degree 1. All right, there we go. That's the factored form of that function. So stop a minute. I'm going to draw a little hexagon or octagon. Stop signs are octagons. Stop. Let's go back and talk about what we were supposed to end up with. So what did we know for sure? We had f of x equals x to the 5th power. So you know what that means? We needed 5 real and complex zeros. Did we end up with 5 real and complex zeros? We did. 1, 2, 3, 4, 5. All right, we're done with that example. Let's go on to the next one. Here in example 4, we're given 1 zero that's complex, and we want to find the remaining zeros, then write it in its linear factorization. So when I see x equals 1 minus 2i, I know that 1 plus 2i will also be a 0. I know that my two factors right off the bat f of x will be x minus 1 plus 2i, x minus 1 minus 2i, and then because this is a fourth degree polynomial, really I just need two more. I just need two more. Let's find those. So right now, so I'm going to kind of like take a little side jaunt here, road trip off to the side. I wanted that to be green. Hold on a second. Okay, so what I'm going to do is I'm going to multiply these together. And you'll see why I'm doing that here in a minute. X minus 1 plus 2i, x minus 1 minus 2i. Actually, I'll tell you why I'm going to do it right now. I'm going to multiply those together. This is going to give me something that I can divide into f of x. When I'm done dividing, I should have another quadratic that I can maybe factor or use the quadratic formula on. I don't know. We'll see. Okay, so x squared minus 1x plus 2xi, negative 1x plus 1 minus 2i, negative 2xi plus 2i minus 4i squared. Looking good. I can cancel out 2xi and negative 2xi, negative 2i and positive 2i, and then also I know that I squared is negative 1. I squared is negative 1, so this becomes positive 4. Okay, this used to be, before it was factored, it used to be x squared minus 2x plus 5. So now that I've done that, well, let me tell you why I did that. I did it so that I could divide that into, I could divide it into the original dividend. So x squared minus 2x plus 5. I'm doing long division now. Long division. I'm doing long division because this is quadratic, and only synthetic division only works if you have linear factors. I need to scroll up a smidge so that I can write down my original function, which was 4x to the 4th plus 0x to the 3rd. Notice how I'm adding that placeholder, plus 17x squared plus 14x plus 65. So I know that very few people actually listen to these videos. You don't listen, you just watch. So I'm going to highlight that 0x to the 3rd, and hopefully people who aren't actually listening to my voice are like, oh, that's why she did that. I see what's going on. Arr, I've got my angry eyes on. Okay, so divide x squared into 4x to the 4th is going to be 4x squared. Multiply 4x squared times 4x squared times x squared, that gives me 4x to the 4th minus 8x to the 3rd plus 20x squared. Then draw a line, change the signs. That cancels out, and now I'm left with 8x to the 3rd minus 3x squared, and I'll bring everything else down. All right, so I'm just going to go about my business of doing the long division. You guys can work on your own here as well. X squared goes into 13, x squared 13 times. Everything cancels as it should. So I know that I found my other two linear factors. So this is going to be, I'm going to do this in a different color as well. I'm going to do this in green. Nah, I've already used green. I'm going to do it in orange. This is going to be 4x squared plus 8x plus 13. Now, factor it. This is 8x. Slide those two together. That's going to be 52 x squared. Oh, I don't know. What's 52? Well, it's 4 and 13, which is not a difference of 8. It's 2 and 26, which is also not a difference of 8. Maybe this won't work. So when factoring doesn't work, try the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All over 2a. Okay, so my pen is not wanting to work. 64 minus 4 times 13. That gives me, I don't know. I'm going to get my calculator. 64 minus 16 times 3 is probably a negative. I know it's a negative. Negative 53. Nope, I didn't type that in correctly. Try that again. 64 minus 16 times 13, or times 13, is going to be 144. Okay, so that's going to be 12i, plus or minus 12i. X equals negative 8 plus or minus 12i all over 8. I can reduce everything by a factor of 4. Let's call it negative 2 plus or minus 3i over 2. Then the last thing we need to do is just write that as a linear factor. So x is equal to negative 2 plus 3i over 2, and x is equal to negative 2 minus 3i over 2. So in terms of the factors that we're going to be using then, what will those factors be? Let me scroll up. I need to fill in the purple part. If I looked at the whole screen, I could just do that from here, I think. So x plus 2 minus 3i over 2, that's an I, all over 2. And then x plus 2 plus 3i all over 2. Now, it's not the most beautiful thing in the world. We should probably break that up into x plus 1 minus 3 over 2i, x plus 1 plus 3i over 2, or 3 over 2i. But that'll do for now. All right, so that's going to be our final answer. We've got a lot going on here. We started by remembering the complex conjugate theorem. If you are given one complex zero, the other one also will be a part of the equation here. 1 minus 2i and 1 plus 2i, they don't go anywhere without each other. Then I erased, I guess. Then I did some long division. After I multiplied those two complex zeros together, I did long division to come up with this part, which I then factored into two zeros and then turned into factors. Actually, I didn't factor. Technically, I used the quadratic formula because 4x squared plus 8x plus 13 can't be factored. Okay, we did a lot of work there. Hopefully you've got good notes and you followed along.